All right, today we're going to talk about drawing molecules, organic molecules. We're going to look at taking a structural formula, going to a condensed and a line structure. The biggest difference in this class is from what you've seen before, before we saw small molecules. We saw water, we saw ammonia. Now all of a sudden we're seeing bigger and bigger molecules. And when you write the structural formula, which is showing every covalent bond in every atom, all right, that's fine. This is butane, it's 4 carbons. Well, what happens when we start to get 8 carbons and 9 carbons and 10 carbons? It starts to get awkward to write this all the time. So we need a shortcut. So we need to go from our structural formula to the condensed formula. Now, when we write the condensed formula, what we have to remember is that every carbon atom has 4 bonds to it. So we basically write the carbon atoms as the backbone with the hydrogens bonded to it. So this condensed formula would be CH3 bonded to a CH2 bonded to a CH2 bonded to a CH3. That's one way of writing it. Another way is just to get rid of the bonds. And there's the true condensed formula. How do you know where those hydrogens go if you wanted to work backwards? Well, you know that you could never make a bond that looks like this. Hydrogen only has 1 bond to it. Carbon has 4. So this would not be correct for hydrogen. So the only way you could write this molecule is if the carbons are in a line. So going backwards, the carbons have to be in a line. 1, 2, 3, 4, and then the hydrogens come off it. And you can see there would be 3 here, 2, 2, and 3. Okay, so that's our condensed formula. If we were going to write the condensed formula for this one, we would have to do the same thing. This would be a CH3, okay? Then it's bound to a CH, which is bound to a CH, which is bound to a CH3. The condensed formula you would see as this. Now in the condensed formula, I didn't show the double bond. I don't have to. Well, how am I supposed to know there's a double bond there? Well, as a chemist, you would write this out, and sometimes you have to write it out the long way to see it for yourself. So that's okay to do. And I would write it back out with all the hydrogens, and I would see, oh my goodness, look at that. This carbon has 3, this carbon has 3, so that means there's a double bond there. So when you work backwards, you need to make sure your carbons all have 4 bonds, okay, when you work backwards. Now, if that is our condensed structure, what's the line structure? The line structure, every line represents a bond between 2 carbon atoms. Okay, so therefore, here there's 1, 2, 3, 4 bonds between carbon atoms. So I would go 1, so this would be 1 carbon atom, 2, 3, 4. Every end of the line or intersection of the line is understood to be a carbon atom. The hydrogens, how do you know how many hydrogens are bound? Because you know each carbon has 4 bonds to it. This carbon has 1 carbon-carbon bond. The other 3 bonds must be to hydrogen. 2 carbon-carbon bonds. The other 2 bonds must be to hydrogen. If I'm going to draw this one, it's the same thing. I still have 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. But between carbon 2 and carbon 3, 1, 2, I need to show there's a double bond. Okay, so that would look like that. That would be 2-butene. Now, what about going backwards? What if I gave you a line formula? What if my line formula looked like this? Maybe we'll make it like that. Okay. Now I have to go backwards and make a condensed formula and a structural formula. The way to go backwards is to remember each of these points is a carbon. So you might want to write that in. Okay? And then what is on the terminal carbon? This must be a CH3. This must be a CH3. This must be, since it's got 1, 2, 3 bonds, this only needs to be a CH. This has got 1, 2 bonds to carbons, so it only needs 2 hydrogens. Only needs 2 hydrogens, because it's got 2 bonds to carbon, and a CH3. So then I would make my condensed formula as CH3, and there's 2 of those. 1, 2. Connected to a CH. Connected to a CH2. Connected to a CH2 and a CH3. There you go. Now, one way we can condense this even further is we can take this section and make it shorter. CH3, there's 2 of those on a CH. And then how many CH2s are there in a line? 2. And then we have a CH3. Okay, this takes a little bit of practice getting comfortable going back and forth between the line structure, the condensed structure, and then the structural formula, where we would draw out all of the bonds. And as you can see, this isn't a very big molecule, but it's already starting to get to be a little bit of a mess. There you go. Our original molecule has just as much information in the line drawing as in this large, bulky structural formula.